Alright, so I spent a bunch of time mounting this to the board, and I had to put it at this angle because the outlet is behind here. Oh, we're going to replace that outlet too, because it's kind of worn out. It's been like that for a long time. Anyway, I mounted the two EP Evers on here. What I do not like about this inverter, it blows air down, not up. So you're fighting natural convection. So it sucks the air in through here, and then actually, the other thing that's stupid is there's actually some holes on the back of this thing here, but as soon as you mount it to something, you block it. So it's lived its whole life sitting on a rack, so it wasn't blocked, but now it's blocked. The wires are too damn short, so the battery has to be over here. This is just a lie time before they changed their name from Amper time. I don't like this battery a lot because it seems like the BMS is overly sensitive. So the cutoff voltage is really, really high. But anyway, it is what it is. So we've got, I need to rewire this, that's why I didn't mount rails on it, but we've got a breaker on the input, and let's see here, we got okay, so the air conditioner just kicked on. I just heard it. So we can see we're pulling a certain amount of amps, and then it'll be like double on this side. But this thing kind of annoys me because it automatically scrolls through the settings, and it'll only stay where you put it for a certain amount of time. I don't remember how many panels are on this one, but I've seen this thing crank out about close to 20 amps after the MPPT. So when these basically are a buck boost converter, more or less. So instead of pulsating to reduce the voltage coming in to a usable 24 volts, it buck boosts, and it takes that voltage that's too high and it actually converts it into usable amperage. I mean, there's some loss there, but it's not as much. See, we have 9.3 amps, and if we come through here, we'll see we're turning the 9.3 amps into 17. That's a pretty big boost. And our voltage coming in is 52 volts. So it's able to negotiate the rest of that and then convert that into amperage. It's just Ohm's law. The voltage goes up, current goes down. Voltage goes down, current goes up. But a PWM, it just pulses on and off and does whatever it does to lower the voltage. Unfortunately, it wastes a lot of power and stuff like that. Whereas the MPPT, maximum power point tracking, has a different system. And it has a buck boost converter in it that allows you to take advantage of the way it works. So, anyway, this one here, we got a 46% load, but literally this thing here is an old air conditioner, and it's a big one, 10,000 BTU, so it draws about 1,000 watts all the time. So a little PWM on the display, obviously. So it'll tell us how much we're pulling from the battery, which gets confusing because it's an all-in-one, and it's basically just easier to know that we're making 779 watts. And this one here, we don't know what the wattage is, but anyway, they're all tied together, and we have a 100 amp hour battery, and the only purpose of this is just to run the air conditioner, nothing else. So I spent all night putting it together so that it could be easily moved if it needs to be. So that's it for that one.